beginning. So who has never been to a lightning talk, an Alfresco style lightning talk? So there's still a handful of people, so I'll explain. But Robin told me I should welcome you to the closing keynote. Thanks for coming. But thanks for coming to Alfresco Summit. I hope it's been useful. So lightning talks are strictly short presentations. They're 5 minutes, 20 slides with 30 seconds between presenters. We have 7 presenters, so that gives us 39.5 minutes of content in a 40-minute session. So that's why we're really strict about how everything works. The gray sign means I've got about 30 seconds left. When it turns red, I've got to sit down because the next person's coming up. We will post the slides, so you don't have to feel like you need to write down all the resources and things. But feel free to ask questions after the session back there, and I'm supposed to sit down.
I won't start talking yet. I've got to keep it exactly 5 minutes. Okay, well, I will start talking. My name is Roy. During the day, I deal with records management, and at night, I play Minecraft. So who here knows what Minecraft is? Anybody? Okay, great. So it struck me that for no apparent reason, I could actually create a mod in Minecraft that would allow us to visualize the Alfresco repository. And that's what we're going to have a look at today. So this is my little fella. This is my skin here. Obviously, it's a Wookiee because I'm an engineer. And this is to give you an idea, if you've not seen Minecraft before, what it looks like. Basically, it's a 3D world, immersive world you can walk around in, and it's all centered around blocks, as you can see. So you can place blocks, you can destroy blocks. Some of the blocks are interactive, so you can build homes or factories or whatever you like. Okay, so the idea is, and I'm just giving you a quick demo of what you can do, build pretty rainbows on the floor and then break them all up. And you can see there's entities in there as well, like cows and mobs and zombies and all that kind of stuff that you can interact with. This is all implemented in Java, and that's why it kind of struck me that perhaps we could do something. It's actually the best-selling PC game ever, and recently just been bought by Microsoft, I think about $2.5 billion or something crazy. So there isn't really a great reason to do this other than I could. I tried to think of some reasons, but this was basically all I could think of. Okay, but it has raised some interesting questions. It certainly gets people fired up. So how do we do this? Well, we use an open source project called Bucket that mods the Minecraft server and allows us to actually build Java plugins. Then we use the Minecraft commands and events as hooks. We use CMIS, of course, to connect to the repository. And then we add what I call construction macros that allow you to use the game to actually build blocks, mini constructions that you can then tie to the data and actually build these structures all together. What you'll see in a minute is that I'm going to show you the entry points. So if down the bottom here, I've got a command. I can go and have a look at my content craft commands, and you can see I've got build, bulldozer, CMS, and macro. So I can run the CMS command and actually tell me that I've now connected to the repository. Okay, so that's my little test command. So that's entry point 1. The other entry point here, I'm breaking blocks. You can see in a minute I'm going to turn on bulldozer mode via a command. And what that's going to do is it's going to listen for the event of the break block, and you can see it's picking up, it's actually breaking the blocks either side. Okay, so that's our kind of entry point. What we do for macroing is it's actually really useful to use the game to build the mini structures that you want rather than manipulating the API directly. So what I've just done is I've started recording a macro, and I do a little mini build. And when I've finished, I can stop recording that macro. And that information about what I just did will be stored actually in the JSON file that I can replay later. So you can see I'm going to run this macro later on. And of course, I do it programmatically elsewhere, and I can start to build sections in Minecraft quickly. So just to show you there's nothing up my sleeve even though it's recorded, this is a normal site. There's some content in there. I will say that in the hackathon, we've actually added books. I can't show you that, but if you want to see it, grab me later. This will run in a minute. There we go. So finally, put all that together, and we can actually visualize an entire site like a library. So I'm going to run my build command and give it the name of the site, which is Content Craft. And then all my stuff in the background is going to kick in, look at the data, and construct a library that's proportional to the number of folders in there. You see I had 4 base folders, and you'll see I've got 4 levels. So first of all, I'm using that horizontal axis for the base folders. We're going to spin around, and you can actually see that the subfolders then run sort of back along corridors, and then each little folder's got a little room where you can put all your books. Again, I can't show you yet because I didn't want to mess up the slides for you at the last minute, But in the hackathon, you can now go in, open the chest, get the book out, actually edit the book, and it will shove it back into the repo, which is pretty cool. In a minute, we're going to go and have a wander around the library, hopefully. There we go. And you'll see that we can also obviously ping all the metadata and put it wherever we want. So when we get up to the next level, we'll see, we can have a look. There you go, it's the engineering folder, obviously. And there we go, we've got a long corridor with all our subfolders in, and we can go and have a look and find the one we want. Obviously, this has absolutely no practical application, so and it won't be productized anytime soon, and nobody please sell it. But the main objective of this is really just to kind of, do something different and try and think about how you could visualize this stuff differently. As you can see, I think we're going to have a look in the chest. There'll be nothing in there, but in the example, you'll see all the books with all the different names, and you can read the text, which is quite good fun. So some of the other ideas that we've had that could be possible is obviously to represent all the users as different entities and mobs. So it means deleting a user requires a diamond sword, which could be entertaining. Another thing we want to try and do is actually make the size of the library actually reflect what's going on in a repository. So actually grow it and shrink it as we go. So hopefully that's interesting. As you see, there's a few other things there. Look out for the other hackathons, because I'm going to be doing this, because sometimes it's more interesting than records management. Okay? All right.
Yeah, let me just turn it that way.
Okay.
There you go.
Okay.
Feel free to start early.
Okay, good afternoon, dear colleagues. My name is Oksana, and I work for ITD Systems company. I am a member of the Order of the Bee, by the way. Today, I want to tell you about the way to capture the content from the legacy infrastructure to the central digital native based on Alfresco. Okay, let's imagine geographically distributed organization. For example, courts all over the country. People in every court working on some cases, and they store case files on local file servers like CIFS and FTP. As far as we have many courts all over the country, we have dozens or hundreds of file servers with thousands of cases on each. And now Supreme Court wants to achieve the data from these servers to Alfresco. Users still will use nearby local shared folders, file servers, but the content should be synced to Alfresco on the regular basis. Cases have metadata. Actually, it's not file metadata, it's case metadata. Judge name, year of filing a case, and so on. So all files inside the case should have the same metadata. This metadata actually lives in a folder and file paths. You can see on the screen a sample. So we have there a judge name, year of filing a case, and a court ID. So our task is to capture the content and to parse these folder paths and fill complete metadata of the case and for all files inside of the case. The same case can be considered by several courts. It's court of first instance, court of appeals, and so on. So we want to search for the same case on different servers and to assemble complete metadata of the case and all files inside of this case in Alfresco. And our task is develop a data spider that will capture the content, parse the metadata, and check for updates. We've already talked about buildings, now we can speak about spiders. So we create sites for all servers we need. Each site has its own configuration, like hostname, login, password, template to parse metadata, and so on. We created a custom repertoire site sync service to do actual job. So it capture content, parse metadata, and so on. The tricky thing is that we check not only for files. Also, we have metadata-only objects, each cases and sessions that are implemented as folders with custom metadata. We need them for search, and we want to search for some case files, looking at their case properties and session properties. To implement it, we have a bit tricky scheme of metadata creation. So site sync service check for the metadata of the file and update not only file metadata, but also case and session metadata. After that, a custom content policy works on updating for metadata of all files inside of the case and inside of the session to make them in sync with metadata of all files of the case. To implement it, we needed a custom versionable aspect. The behavior of the versioning is a little bit different, and I have no time to tell you about it in details. As far as the same files we can store or have on different file servers, we don't want to store the same file several times in the repository, so we use some deduplication method to work on it. It's already in production. Russian Supreme Courts use it in more than 100 courts all over the country. If you're interested in details, feel free to find me during the break. Our next steps is to refactor it for greater flexibility. So now it's about courts. We should work not only with courts. We want to add callbacks to query third-party systems to check for the metadata of files from it, and so on. Here is the repository. Actually, it's empty, but after we will refactor the code, we will publish the code to this repository. I believe we will do it in several days, weeks, and so on. We can already show you the code. Thank you. Take it.
Hi, I'm Axel Borroy. I'm working for Keensoft, and I'm a proud member of the Order of the Beat too. So we are now to see a journey from Venus to Mars, from sunny developer land to cloudy real world. Because we have now Maven SDK, Alfresco SDK, plenty of features in order to enjoy as developers, boxes, and reloading and all that kind of nice things. But in real world, we have several environments. We have test, pre, pro, and the integrated system has these environments too. So we are crossing environments, and we are using a lot of properties in each artifact. For repo artifacts or for shared artifacts, we have properties targeting different systems and different environment of each system. Even we have shared properties between repo and shared artifacts who need to be in one place, because if they are in every artifact, we can fail. We can use the global configuration in Alfresco in order to include our properties, but we have no possibility to have these properties by environment. In the share side, we have no visibility of the global properties, so we have to include our properties inside our modules, and there is no possibility to share these properties with the repo. Our approach is going from source code to AMP modules, to packaging. We are using some Maven facilities. Firstly, profiles in order to define the different tests, pre or pro environments. We are using the properties Maven plugin in order to read the properties for these environments, and the Maven and Run plugin in order to package all these properties in different AMPs. Our property files are prefixed by environment. You see this test pre and pro property files, one for each. We define on the root POM our environments, again, test, pre, and pro, just a sample. You can define everyone. And we are using the Maven properties plugin in order to tell the modules where the properties are. We are using the env parameter in order to tell where the properties we are packaging are. And then finally, we are moving all this AMP to a folder in the same structure for Alfresco, amps and amps share structure. So we can use the values in both modules, in repo or in share, in the common way, maybe injecting in a Spring Bean or in a message or in another common way. And by packaging with one parameter, we can have a ready to deploy amps per environment with the test artifact, a pre artifact, and a pro artifact. And is this useful? Sometimes is it. This is a real case. We have to integrate Alfresco with a signature service. And we are using server signature services, client signature services, and verification services just from repo and from share module. So these share properties have to be in one place. In our way, we define the properties. This is a sample for the pre-environment using the server properties, the client properties, and the share verification property. This is an URL of the pre-system. And in our artifacts in the repo, we are using that parameter. In the share, we're using the same parameter, so we have in one place our URL. This is nice because we are extending Alfresco SDK capabilities, and we need just only one additional parameter in our compilation. So thank you very much.
So hello from me again. My name is Axel Faust. I work for a German partner called Prodyna, and I'm going to talk to you about a little side project that kept me occupied the last 6 months. This is a proof of concept project that I did, and it's actually about replacing the Rhino script engine in Alfresco with the Nashorn script engine that is available in JDK 8 and above. And I did it for several reasons. One, similar to Roy, because I could. The other one would be that Rhino has aged not very well. I mean, it's been in Alfresco for ages, and it has some issues. It implements a very old standard of the ECMAScript specification, and it's not up to date anymore. On the other hand, we have Nashorn, which is a very recent addition to the JDK platform. It is actively being developed by Oracle, so we know it has the newest features of the Java platform built into it, and it supports one of the newer standards of the ECMAScript specification, or more, the newer versions of the specification itself. So it should provide us with a better scripting experience. And one of the features that Nashorn makes use of is the invoke dynamic bytecode instruction in Java 8, which allows for better performance when calling native Java components from dynamic languages such as JavaScript. But also we have some other improvements, for example, persistent script caching or dynamic linking to resolve the Java objects. How much faster Nashorn actually is a matter of how you measure it. These benchmarks measure 2 scripts in both engines in 2 different scenarios. The bigger difference between Nashorn and Rhino on the left diagram is due to the script caching of Nashorn, because it eliminates any recompilation when you pass the same script string to the eval function multiple times. The right diagram uses precompiled scripts, and the difference here is due to the invoke dynamic bytecode instruction, because only the second script actually has about 100 calls to Java code contained in it. Apart from performance improvements, Nashorn also provides full support of Lambda and single abstract method interface concept, which allows us to easily pass a JavaScript function as a callback to Java code, and it will automatically be converted into an instance of the interface that is required. Furthermore, Nashorn provides better handling of native primitives in JavaScript. For example, comparing strings, which was a pain in Rhino in some instances, is now a breeze in all instances I could test. Also, lists and maps now feel like native objects without having to be converted. If you're running a Nashorn application with a security manager in Java, you also benefit from the added security. You can actually write policy files that define what a script can access in terms of Java API, so you can really differentiate the security, not just have secure and unsecure scripts like in Alfresco standard. Replacing Rhino with Nashorn is not just a matter of putting in a new script processor. There's a whole lot of existing script API as well as custom extension code that needs to be considered. And they all use the Rhino API in some way. Primarily, they use it to expose the features to the scripting tier, for example, their operations and methods, but they also use native objects, like scriptable object in this case, to pass around values as parameters or responses of operations. And those operations in a Rhino-based bean also require specific execution context and execution scope to work correctly. And all of this is not compatible with the Nashorn engine, Nashorn environment by default. So I had to find some tools to make them compatible and be able to use the existing API in a Nashorn context. And the tools I chose were using subclass proxies to transparently adapt any existing Java-based component of the script API and custom extension code, and value conversion to handle the interchange of data between Nashorn environments, Nashorn native objects, to the Rhino-based objects. One of such proxies is the JSObject proxy. JSObject is similar to the Rhino scriptable interface and allows us to expose any Java object as a native-like object in JavaScript, while still having some control over how it's done. And by extending an existing component, for example, like script node with JSObject behavior, I was able to intercept any calls to it, perform the necessary value conversion, and give it the correct context to work correctly, even if it's running in a Nashorn environment that has full access to Rhino context. Unfortunately, not every Alfresco class allows me to do this. I actually had to write some bytecode instrumentation to remove the final keyword of some classes when they are loaded into the virtual machine, so I could subclass them using proxies. I also had to write some additional signature mapping to provide better input to the value conversion process. Currently, I've migrated the repository of Alfresco 4.2 to support running share on top of it. And as of this morning, it also supports running the JavaScript console with the Nashorn script engine. So it's actually gone a long way. In the future, I would like to migrate the remaining tools of the enhanced script environment to Nashorn, evaluate any tooling around debugging of Nashorn scripts, and finally start migrating the share tier. Though Nashorn has made me kind of a fanboy in terms of not wanting to go back to Rhino, it has some issues I would like to see addressed. I would like to have some improvements in terms of how I can customize Nashorn to embed into my system, for example, respecting multi-user context, local and time zone information, for example. And before we can actually see Nashorn in Alfresco, there's a lot of effort that needs to be done. The most significant one would be a complete refactoring of the script API to remove any Rhino specifics and allow multiple script environments to use these APIs. Please keep up with further updates as they come.
Okay, hi everyone. My name is Aingaran Pillai. I'm the CEO of Zaizi. I'm sorry for everyone who has been in my earlier talk. I'm going to cover some of the topics. One of my colleagues was going to talk all technical in this, but he couldn't make the event. So I'm going to talk about how we're going to power Alfresco with a lot more metadata to power the faceted search. So I'm going to talk about semantic enrichment using linked data, pulling the knowledge of the web and pushing it into Alfresco to power the new faceted search solution in Alfresco 5. So what is semantic enrichment? Well, effectively, it's taking text, doing some detecting names of people, places, organization, and linking it to the linked data cloud. Here we're using DBpedia to link Usain Bolt to DBpedia entry for Usain Bolt. And here's the information on Usain Bolt in DBpedia. So it's got his birth date, where he was born, all this information. We can pull this in, and we can push it into Alfresco for Solr to index and provide it as search, or tag it in Alfresco as metadata. Right? And the other wonderful thing about DBpedia is it's multilingual. You've got, at the bottom, you've got different labels for Usain Bolt. So how do you spell Usain Bolt in Japanese, in Korean, in Russian? So if once it's in Alfresco, you'll be able to search for Usain Bolt in Russian and find any document that talks about Usain Bolt, because we've got that. And the way we do it is we use a SaaS service called RedLink, which provides all of the clever linked data extraction stuff, you can go up and you can sign up for a developer API. And that's how it's built. It's based on open source technologies. It uses Apache Sample, Solr, Marmota underneath. At the moment, it'll do text, but they'll hopefully add video at some point. And then it pushes it out on the other end, either into their Solr instance, or you could get it down into Alfresco and do it. Apache Stamble is an open source Apache project that does semantic enrichment. So it's quite popular, and it's getting a lot of traction in the market out there. So it's just graduated from a incubator project. The other one that does the linked data stuff is Apache Marmota, which is all about linked data publishing. So this is where you take DBpedia or any other data source from the linked data cloud, and you can push it into your ECM or publish out from your ECM as well if you've got your metadata. This is what the RedLink portal looks like. You'd sign up, you say, I want to create an app, and you start adding all the various data sets there. You've got DBpedia. You can also add your custom data sets as well if you want to enrich against your internal data sets, but you've got lots of data sets there. This is how you create an app. You go in. It's as simple as you drag the components you want to do, give your name for your app, and when you save it, you get an API key, and then you basically use that to make your REST services. It's as simple as that. There's some examples of apps that I've configured, and there you see you've got the API key, and then you can just use that to call the RedLink REST API. So I've created a custom app there with UK company datasets that'll effectively tag any content with UK company information. So the way you integrate that with Alfresco, we've done a RedLink plugin for Alfresco. So that's on GitHub. It says hasn't been updated in 7 months, but it was updated today. So that's an old screenshot I took yesterday. So you plug that in, and what you do is it's a little amp, and it'll let you configure content rules. So you go, you set up a content rule, and you say, I want to enhance the content in a particular folder. So you click enhance. I am talking too fast. But and so what it does is when you upload data in, it'll tag all the content. So here we've got some information on sports, tennis stars, and it's actually identified places and tennis players. And it also adds it as a separate entity. So I don't know if you can see that. You've got places, organizations, and people that have been listed down there. And you can click on it, and it'll pull back more information as well. And actually, if you do click on it, what it does do is, and the reason you would do this is obviously to provide better search. So once you put it in, you could do searches, and then you can search by concept. So, you know, the auto suggestion and complete, you start typing in, it brings you back. All those pictures and images come out of Wikipedia. You can also search by concept. So here we're searching by football player. So not looking for anything particular, but looking for all content that talks about football players. And that's automatically done because we've linked it to Wikipedia, and Wikipedia knows what a football player is. And obviously the multilingual capability. So here we're searching in Arabic for football player, and it'll bring back all content that talks about football players. So you could do multilingual search. So the plugin doesn't do this at the moment, but we're planning to build this into the plugin. This is a prototype. And you know, Google does this today. So if you go to Google and you do a search for Larry Page, so the stuff on the right is coming off the knowledge graph. That's effectively what we're doing in terms of how, when we integrate it with Alfresco, is providing this search. The next step, obviously, where we want to take it is to do this within the enterprise. So, you know, you can imagine that you've got public data, but you've also got private data from your internal repositories, like your HR system, and you can connect them all up, and then you could really enrich your content that you store within Alfresco. So there's the information on where you can get the GitHub stuff and the demos.
There you go.
Hello. My name is Samuel Langlois. I work for Alfresco. I take care of the build, the releases, and the continuous integration. I took a lot of time in the last 2 years to Mavenize the product as well, the build of Alfresco itself. I'm not going to talk to yeah, you can call me Sam the Builder if you want. I'm not going to tell you about Maven today. I wanted to tell you a bit more about how we are organized inside Alfresco engineering to provide you with the best ECM software that the world has ever seen. So Alfresco is open source. You have access to the source code, except that you only see the head branch, the so-called head branch of Alfresco. So if you look at the commits on head, here is what you can see. You can see a big spike every 3 weeks. And then in between those spikes, we go on vacation for 2 weeks. No, we don't. Of course, what you see here is just the tip of the iceberg. There's a lot of things going on under the surface, and I wanted to tell you a bit more about that today. Especially, it changed this year in 2014, because after the release last year of Alfresco 4.2, which was a bit painful to release, what was happening is that everyone was commenting on a separate branch, and then in July 2013, everyone merged at the same time, and then it took us 4 months to recover from that, test everything, and fix all the bugs. So that's because we have more emphasis on quality in Alfresco now, which is good, but we don't want to make the release pace slower because of that. So we need to be more agile, and we need to work in smaller teams. So what happened is that we splitted the big engineering team into smaller teams. 4 teams, 3 were server sides. You have the platform team, which takes care of the core repository, and the 2 web teams providing web interfaces on top of that. And there is another team which is a bit separated because it deals with client-side apps, Android, iOS, so I'm not going to talk about them. They work on a different code base. Each team has a 9-week cycle. They have 3 weeks sprints, 2 development sprints, and then 1 release sprint. And at the end of the release sprint, they merge everything onto integration branch, which has a funny name. It's called Head Bug Fix. You can see this name in the comment messages, so I put the right name. So each team releases every 9 weeks. When it's stabilized on Head Bug Fix, we then move it to Head, and this is where the big spike on Head happens. You can see where the commits are. And usually we do a release on the cloud as well, on myalfresco.com, so that you can see what's going on. Because we have 3 teams, and they are all aligned and shifted, so we have a release every 3 weeks of a different team. I hope that's clear from the slides. Of course, it's a bit more complicated than that because we also provide service packs. So we have a branch which is deeper called V42 Bug Fix. Once again, a funny name, which constantly gets some modifications, some fixes for service packs, and will get merged onto Head Bug Fix. And we have a V41 Bug Fix as well, which gets other fixes, which get merged onto V42 Bug Fix, and then Head Bug Fix, and then Head every 3 weeks. Of course, it's a little bit more complicated again, because we also have hot fixes. So what's a hot fix? We have this customer who is running 4.16, Alfresco 4.16 in production. He doesn't want to upgrade. He doesn't want to break everything, but he wants just that fix. So we take that 4.16 tag, we copy it into a branch, and we fix just that bug, and we provide a 4.16.1, and then we merge that onto the 4.1 bug fix. So you see that it skips the 4.17, and it will be integrated in 4.18 service pack. And then this will get merged all the way up to Head after a few weeks. And you will see that in the next cloud release. Then you have, of course, a very big tree of branches, which I drew here. This is all the branches of Alfresco. We are very happy with the change. Being more agile allows us to provide releases to the cloud, which is good for customers. We have happier developers because we have smaller cycles, more releases, which is good. To go a bit further, I think what we really need to do now is to take that big piece of monolithic code and break it into smaller chunks, but it's going to be a hard work. If you want to know more, you can come and chat with me because there is nothing public about that. Thank you.
You want this one or the handout? That one. Okay. So I can go in your pocket. Yeah, thanks. Hi, my name is Rich McKnight, and I'm going to talk about encryption of global properties. What we're going to cover on our roadmap through this talk today is
why we would encrypt global properties, a look at the implementation that we had, and how we configure it, and where you can actually get it. Now, if we think about why would we want to encrypt global properties, the biggest threat to data security comes from within the organization. Many organizations have policies to limit access to content and critical data and content sources. And as a result, we have to protect the data and the content that's in the enterprise. One of the ways that we can do that is limit the access to back-end components. If you remember that Alfresco repository has the following components. It has metadata that's in the database, it has content which lives in the file system, and it has the indexes that live on the file system. Now, a rogue employee with read-write access to the database and the file system could gain access to restricted content, modify the state of the repository, and do all of this bypassing all of the auditing. If we encrypt the data, if we encrypt certain things like if we limit access to the data, to the back-end components, then we can keep one rogue developer from doing all of this. And the way that we do it is by encrypting the properties so that they can't get access to the data system and to the database, to the file system and to the database. Who's asking for this? We have government agencies asking for this, financial institutions, healthcare organizations. Any organization that has sensitive data is asking for this. The way we did it was we used the Java simplified encryption library. We use a public key to encrypt the sensitive properties, and we use a private key to decrypt the sensitive properties. The encrypted properties are exposed using the same methods that we use for the regular properties. Now, we have to provide some tools. We have a public private key generation utility that generates those keys. We have a property encryption utility that can take the private key, the public key, and generate the encryption. And then we have ways to actually include those files. We have the property placeholder configurers that we use for the repository properties, the shared properties. And so you see global properties, repository properties, and shared properties come in that way. We also have encrypted properties that have a special extension of these placeholder configurers, and they use the public-private key encryptor to actually load up the encrypted properties. Finally catch up. Now, we don't use the names, the key store, because the location of the key store is defined in the properties file, and that information is not available at the time that we would need access to the private key. So the private key is located under Alfresco Home. So how do we configure it? We generate the public and private keys, we protect the private key, we generate the encrypted values for the sensitive properties, add them to the encrypted properties file, and use those encrypted properties in the Alfresco global properties. The way we do this, we have the key generation that we go through, then we have the public key and the private keys that's generated, and then we use Chmod to actually protect the private key so that nobody can go in and get access to it who's not supposed to. Next, we take the plain text property, we run the encryption utility, which uses the public key, and it outputs an encrypted property that we would then use. So we take that encrypted property, we put it into an encrypted properties file, and create it. There's a special format for that, which we will see on the next slide. So you'll notice here that we have db password.encrypt, and then we have this ENC, and then this is the long string that was generated when we actually typed the encryption utility. So you would just cut and paste it, and it would give you the information. By the way, and then after that, so once you create this encrypted file, then you would have to use those encrypted files in the global properties file. And so we can load that file and dereference it much in the same way we would reuse any other property in the Alfresco global properties file. So if you look here, we have dbpassword, and then we use dbpassword.inc. So this knows how to dereference it, take the plain text value, and use it in the Alfresco global properties file. So how do you get this? This will be part of Alfresco 5.0. I've watched as they've gone through the QA process, and it's been quite fascinating, watching the JIRA, but it'll be available in 5.0. Now, if you can't wait, then you can consult support regarding the availability of a 4.x version of this. We have it. It's in a knowledge base article, and so we can make it available if you can't wait. Thank you very much.
That is an exhausting amount of content. I'm very impressed. Thank you for all the speakers for presenting. Thank you for the excellent content. Thank you for attending. I hope you enjoyed Alfresco Summit. Perhaps we should invite the speakers to hang out outside the door a little bit, or I guess this is the last session, so you can stay in the room. So if you have questions for the speakers, maybe you guys can hang around a little bit. But thank you very much. Let's have one more hand for the speakers.